How can a poisonous gas and explosive metal be essential elements? How is that? In one brief sentence.
Just lucky, I
I missed it, what?
Just lucky, I guess.
We are. I promote God. I say, God, there is a divine maker because it's so elegant and simple. The other problem with chemistry is protons and neutrons are big, right? Everybody's got this big, like we're all from Texas now. The United States is Texan, big, everything's big. Protons and neutrons, right? That's chemistry, huh? That's where all the mass is, right? Chemistry is the electrons. It's the little teeny weeny little 1/1832, whatever a proton is. The mass of an electron, that's what chemistry is. Do you ever hear anybody saying that? That's why I'm doing stuff. It just isn't condensed in a way. The electron is chemistry. If I wrote a book, I wouldn't even talk about protons or neutrons until chapter 4. I'd start with electrons. Point being, sodium and chlorine make sodium chloride. So over here you got your sodium, over here you got the chlorine in some crystalline lattice, right? Three-dimensional. We all seen those models up on the top of the things everywhere. Nobody ever gets them down and plays with them. That's why I love this kind of stuff. You're playing with it. You're in the reaction, you know. I do this with the old folks. I go in, I go to the florist, I get all their old flowers, I bring the old folks. What's the activity director do with them? Puts them in a vase and puts them up there. I'm like, give them to them. They're sitting there picking the petals off and having fun with, you know. Nobody does that. They put them in a vase and they look at it. Sodium chloride crystalline. You put that in water, what happens to it? Into what? This is what I learned studying chemistry. You gotta say the word ion. Without ion, and when I read books, I'm like, don't call it sodium. If it's sodium ion, you need that AQ thing in there. You need to know that that is dissolved in water. Now, this is the periodic table. When you look over here, this column 1, what is that column 1? Why is sodium in column 1? It's got one electron on the outside, right? So when this dissolves in water, I love chemistry. I wish I could go into all this. Activity, remember those numbers and stuff? You consider the difference between sodium and chlorine. It says it'll dissociate. Chlorine holds the electron to fill the octet, right? This is what you're going to see on my table here. Chlorine's going to have an empty flower, just like all the other halogens. So when you take this and you fold it, what you see is the one little flowered asterisk for sodium is going to be given up to the chlorine. So when this dissociates in water, you've got sodium without its electron, a plus charge.
Would you like to advance out your tables?
Not now. I'm not going to just distract you.
You'll look at it.
The negatives on this are like hands. When the elementary people come in, I'll show you how to draw this.
We're here.
Oh, are you all there? You all got paper? Draw this, because it's really priceless, I think. And I'll show you how this happens, because it's got to be ions. Without ions, you just got noble gas. So what I say, when you got a noble gas, it doesn't react with anything, right? What kind of chemistry would you study if nothing reacted? And how do atoms and elements and molecules react? By electrons. So if you got a noble gas, there's nothing to study. It just goes around. But now you've got, we're going to go back to the space shuttle, okay? That orange tank has, what do we decide? The oxygen, the heavier is up top, which is backwards. It takes more energy to pump that O2 up. You know they got to empty that every time they scrub it? Did you know that just the carboxylic acids in your fingerprint on the inside of that thing is enough to combust and light it? One fingerprint inside that will light the LOX box. See, this is where it gets learn chemistry. This is cool stuff that they do with the shuttle alone. Okay, LH2. The balanced equation, we've got H2 H2 plus O2 goes to make H2O plus the energy to launch that thing. This is why water holds so much energy in the bonds, the electron bonds of this thing, right? To balance the equation, there's two H's, only one O. Two O's are going to have to be split, so you're going to need twice as much of the hydrogen. But when you look at the picture, you know, right? More hydrogen, so you must need two to get the balanced equation. So again, like fractions, that's, everybody should know this. The opposite of that, well, it's kind of the same combustion, your sugars in your body, you know, it's the photosynthesis that would have gone on in the glucose. How do what I say? I'm a research biochemist. Trust me, this is really what water looks like. Two H2Os is what we're going to draw. I need the green. See, that's the one I was missing. That's what we're going to do. Anybody hear color line? This is green. Two oxygens. What's the atomic number of oxygen?
8.
So we'll put an 8 in here so they know it's 8, right? How many electrons on that inner shell of oxygen? Right? So we'll just put 2 in here. I make it simple, but I don't want to cheapen it. So I want to make sure you got all the electrons, everything that should be in there. So 2 inner shell electrons. Now we need the octet for the oxygen, right? It's already got 6. I'll draw those last. But how many hydrogens are there on water? I've already showed you the balloon part, right? So when we do, it looks just like the balloon, right? The atoms, molecules, protons bond by pairs of electrons. So there's 2 in here, 2 in there. That's 2 4. We need to get 8. So in 3D space, outside of this, you know, technically these would be further apart, and they're close. Have you ever seen when they do the angle, they're pushed together to the electron pair? Remember the negative stuff of that? Are you guys following me? We got elementary. This is what I was talking about before. 2 electrons, shouldn't they be repelling each other? They're negative. Have you ever thought of that? This is like the same thing. How does an electron and a positron, both having mass, come together and make a photon that doesn't have mass? I'm sitting there in physics going, wait a minute. And everybody else is just like, you know, copying away. She didn't even explain it to me. It took me 5 years to figure it out. If you want to know, ask me. It's really interesting. Anyway, they're called Cooper pairs, the electrons. Physicist, another guy, got the Nobel Prize for this. Why do electron pairs stick together? Because out here in space, you've got one pair, and then you've got another pair. So this is what I call, it's a shame we use the word mole, because moles have such a negative thing out there. You know, everybody pictures moles being beady-eyed and stuff. So it's too bad it couldn't be a mouse, you know. Could I have 3 mice of hydrogen sulfide or something? But it's moles, so what I call this, in honor of my mom's passing, she was a McCarthy, so we made her Mick E. Mole. And this is Mimi. So I try and tie the electron into it. I'm ready to go sloppy here. Mimi Mole. So when I did the periodic table back in like 95, I came up with the Vicky Mole thing. I called Oakland Schools. I said, give me your worst guys, man. I want to see if this is as powerful as I think. Just the folding of the table. Because the kids in Sonoma State weren't getting the ionic combinations, you know? Because when you go over from this, you're going to see the calcium chloride. You need 2 chlorines for the calcium. But nobody draws the electrons on the table. If we had one here, you'd see that the Roman numerals on top, that's the number of valence electrons. But people don't even know Roman numerals anymore. The younger people. The older ones don't take that personal, but we can still read. Now it's easy with 2000, but remember the movies at the end, they'd have MCM, you know, we could go, oh, that's 1973. You know, now kids go, what's all that? Anyway, the point is, water is a magnet. You got a plus side